Okay, let's do one more example here, and I think we're just going to call it good after this one, but this one has a little bit more to it. Just like we did last time, go ahead and make yourself a list of what we have. If I can find the mouse on my screen, there it is. Make yourself a list of what you have so you can see what you need to figure out, and then get started down that path. And I'll check in with you here in a minute and make sure we're pointed in the right direction. Also, that says 23.07 degrees, if you couldn't read it, 23.07 degrees. All right, so if we get sine of b equals this mess equals that, b equals 65.16 degrees. Okay, 65.16 degrees riding up the hill. If we subtract those guys from 180, and if my fingers push the buttons correctly, then that gives us a c equals 91.77. And we can go back and find the c here in just a moment. Okay, now the thing that we always need to check, and so we'll go back and make sure we haven't done something or left some information out on the other ones. We've not done anything wrong in what we did, is we know the sine function is positive in two quadrants. Okay, the sine is positive in the first quadrant and the second. So the sine function also, I'll get back to black, would be positive for something in the second quadrant with a 65.16 degree reference angle, meaning 114.84 degrees. Now, if we come back over here to our triangle, and if we consider for a minute b being 114.84, we could pretend that's what that says right there. We have to say, is it possible to have a triangle that has these angles? So if we add the 23.07 to it, we're still less than 180. And we find out, sure enough, we could have a triangle with this angle. Okay. Sometimes we'll find out with the information that we're given there are actually two triangles here. And so I'm going to kick back to the other examples here for a minute before we finish this one to make sure that we didn't leave something out. Okay, because now I know that along with finding this blue C here, I'm going to, for these same black values, plug in 114.84 for B, which will give me a different capital C, which will lead me to a different lowercase c. So here that wasn't a problem because that wasn't possible to begin with. This one, when we found angle C, get my mouse to move, to be 4.5 degrees. Okay, if we look in the second quadrant and find an angle that has a reference angle of 4.52, so 180 minus 4.52, it says my other angle would be 175.48 degrees. Okay. If I came up here to angle C and made this angle 175.48 degrees, could I have a triangle? Is that a possibility? Hopefully you're saying no, because right now those two add up to 275 degrees without even putting the B in. So if we say, well, in this case, there's not a second option, not a second possibility. And if we came back here, our other two, there was only one option because two of our angles were fixed. Okay. So in the law of sines, because the sine function is positive in the second quadrant as well, we always have to take this second angle into consideration and see if it's possible to build more than one triangle with these three black numbers. Okay. Since there is, we've got to go back to the blue values and say C over sine of 91.77 degrees, and yes, I'll go get my degree signs up there in just a moment, is equal to 9.5 over the sine of 23.07 degrees. And then we can figure out what C is. Okay, and then we'll have to go back again and do the same thing, finding our purple values. Go ahead and pause the video, see if you can finish and find this C, and then go back and find the other C that we're going to need. All right, so I recopied on the right slide what we had in black on the left side slide. And instead of the 65.16 for B, I plugged in the 114.84. Okay, again, we can add up angle A and B and subtract from 180 to find out that angle C is 42.09 degrees. Then we can say C over sine of that angle equals 9.5 over sine of that angle. And to 2 decimal places, C equals 16.25. Okay. Again, I'm using an extremely primitive calculator, probably at least as old or older than those gray ones in my classroom. So if my finger slipped, if I hit a button wrong, if you're not getting what I'm getting, I mean, you have the expressions that I have written up there, but your calculator's saying something different, then give me a shout, and I can post a correction if I need to. But here is the law of sines. And the next video we'll talk about finding areas of triangles.